All right, guys, Mr. Antonucci here, and today we want to calculate the average value of a function. And we're going to use this example of 4 minus x squared on the interval -2 to 2. And I'm going to show you a couple ways of calculating this value. And I also want to show you some of the things from a graphical perspective. In fact, let's start off with that graphical perspective. Again, I'm using DESMOS. This is a very powerful free graphing calculator program. So if I do f of x equals 4 minus x squared, you get our function. And we're going from x equals -2 to x equals 2. Okay. And those are actually the roots of the function. And so what we're actually calculating here is the average value of this function. So the function takes on heights from a height of 0 here, it increases up to 4 and then decreases back down to 2. And how we get average value is you take the definite integral of the function over that interval. So we're going to be calculating the definite integral from -2 to 2 of 4 minus x squared dx. And that gives you the area under the curve. To get average value, you have to multiply that by 1 over the width of that interval. So it's basically going to be b minus a. So in this case, -2 or 2 minus -2. Now, think about it like this. The definite integral is going to calculate your area. And this fraction here is 1 over your width. And if you think about area as a rectangle, when you take the area of a rectangle and divide it by the width, you're going to get the height. Now, I know our region isn't a rectangle here, but that concept kind of holds true here. What we're doing is we're calculating the area under the curve, multiplying by 1 over the width or dividing by the width, and that's going to give us our average height. Okay, so let's clear that off. Let's go back to our work here and calculate the value of this function, or the average value. So I'm just going to put AVG equals 1 over b minus a times the definite integral from a to b of f of x dx. Now this is the general formula for average value. For our particular situation, it's 1 over 2 minus -2, b minus a, times the definite integral from -2 to 2 of 4 minus x squared dx. This fraction right here can simplify to 1/4. And then to evaluate a definite integral, remember we take the antiderivative. So it's going to be 4x minus, and remember the antiderivative of x squared. To do x power functions like this, you add 1 to the exponent, multiply by the reciprocal of the new exponent, and that 1/4 is going to multiply that whole expression there. So evaluated at -2 and 2, and we'll go from there. So you got 1/4. Now you plug in the upper limit, which is 2, so 4 times 2 minus 1/3 times 2 cubed minus the function evaluated at the lower limit, so 4 times -2 minus -2 minus 1/3 times -2 cubed. Okay, now we have 1/4. 4 times 2 is 8. 2 cubed is 8 times 1/3 is 8/3. So that's that set of parentheses. And again, I've talked before about the importance of parentheses when you're subtracting quantities. Lots of times students, I've noticed, make mistakes with negatives when they don't include the parentheses where they're necessary. 4 times -2 is -8. And then this is going to be plus 8/3 here. -2 cubed is -8 minus or times the 1/3 would give you -8/3, but you're subtracting it. So it becomes positive. Okay, so 1/4. Now 8 you could think of as 24 thirds. So we get our common denominator and subtract, and you have 16 thirds. Minus, similar thing going to happen here. -8 is -24 thirds. So you subtract and add, or excuse me, -24 thirds plus the 8 thirds gives you -16 thirds. Okay. And so 16 thirds minus -16 thirds, subtract the negative, you add, and you would get 32 thirds. Now this 32 thirds represents the area, and the 1/4 is the width. This is what we're actually calculating. When you multiply that together, you would get 8 thirds, and that is the average value of our function. Now I want to show you graphically what is going on here. What we just calculated was the area under this curve, and that was the 32 thirds. When you multiply by the 1/4, that gives you the average value. Now, if I graph the line y equals 8 thirds, that horizontal line at 8 thirds, that's the average height of the function. If I shade the rectangle that height gives over the interval, shaded it in red here, this is this rectangle here, okay? That area of that rectangle is the same as the black area under the curve on that same interval. It's kind of like if the area under the parabola there were like water or some kind of malleable material and you flattened it into a rectangle, that's the amount of area that it would take up. So hopefully that's helpful to you in understanding that. I want to show you one other slick trick with evaluating this definite integral. Let me go back to my screen share here. If I take off the average value there, notice that this parabola on this particular interval from -2 to 2 is an even function, and it's a mirror image of itself. What that means is that the area in this right half is going to be equal to the area on the left half. So we can use that to simplify the process of evaluating our integral. Watch. So if I just do the integral from 0 to 2 of this function, okay, that will give me half the area. Because of the symmetry of the function, I can just double that. So multiply it by 2. That's why I'm doing that. Now you might ask, why would I do that? Well, because now the lower limit is 0, and it's a lot easier to evaluate and much more efficient and faster when your lower limit is 0 in a lot of cases. So just be careful of the work here. This 1/4 comes from the average value definition. In this 2, we're doubling the area under the curve from 0 to 2 because of the symmetry of the function. So that's going to simplify to 1/2 times 4x minus 1/3 x cubed. And we go from 0 to 2. So you'd have 1/2. And then plug in 2. So 4 times 2 minus 1/3 times 2 cubed. And then if you plug in 0, you end up with 4 times 0, I'm going to run out of space here, minus 1/3 times 0 cubed. Okay. And then if we move our paper up a little bit, this is going to be 1/2 8 minus 16, not 16, 8 thirds. This is why I always do math in pencil. And this is just going to simplify to 0. So you'd have 1/2. Remember before we did 8 is 24 thirds. So that's 1/2 of 16 thirds. Now look, 16 thirds is half of what we got previously for the area. Remember, we just got the area from 0 to 2, so it should be half of the area from -2 to 2. Okay, and that's why we multiplied by 2 up here. Now that 2 canceled with the 1/4, so now at the end we're only multiplying by 1/2, and you still get 8 thirds as your final answer there. Okay, so hope that was helpful to you. If you have any other math problems dealing with calculus, trigonometry, pre-calculus, Algebra I, Algebra II, put it in the comments below and let me know, and maybe I'll make a video on it. Make sure you like this video, comment below, and subscribe, and hit that bell for notifications when new videos are uploaded. All right, guys, have a great day. Hope that was helpful to you. Take care.